Hi, my name's Adam Zufall. I'm a graduate student here at the University of California, Davis in the Center for Space Exploration Research. And as you can see by the title, I'd like to tell you a little bit about the thermal response of a Raspberry Pi CM4 that we've been operating in orbit for about 2 months now. The hardware, the compute module is mounted on a COTS I/O board. The important thing here is we've noticed in ground testing that we were drawing about 3 to 4 watts while our code was running. And the processor there, for context, is about 14 millimeters on a side, so you can get a sense of how concentrated that heat load is on a single component. And important for this conversation is the CM4 will actually start to throttle. It will start to decrease its clock frequency at about 85 degrees Celsius. So remember that number when we're looking at these plots. And the I/O board is nothing special. It's a COTS component. You can see it there. We're not actually using all of those peripherals in the spacecraft. We're just using the GPIO connections. But again, those COTS components in the CM4 were selected to decrease development time for our payload. And as I mentioned before, this was integrated into a payload that was then installed on a much larger spacecraft, and it was launched in November of last year. So we've been doing on-orbit operations for about 2 months now. So the first time we booted up on orbit, you can see the thermal response on the left and the clock frequency on the right. We only operated it for about 30 minutes. Again, this was just checkout to make sure all systems were working as they should. We saw the temperature go up, but the frequency was stable. So no problems there. What's much more interesting was the second orbital boot. We ran it much longer, and you can see that eventually we kind of plateaued on that temperature. So that the temperature was still increasing over the first hour, and then we reached that throttling limit of 85 degrees Celsius. And at that point, then the clock frequency started to decrease to maintain a safe temperature. The good news is the CM4 continued to operate, and it didn't have any adverse effects on our payload at this lower clock frequency. But again, if that's something that's concerning to you as an operator, it's something that you should be aware of. If we extend the time axis out further for, again, looking at this second boot, you can see over about now 2 days of orbital operations, the temperature fluctuated a little bit, and the frequency fluctuated as well. So that orange line is a rolling average of all the data points to kind of smooth it out a little bit. And what I thought was really interesting was when the temperature dips down just a little bit, that average temperature, the clock frequency, again, average frequency, clicks up just a little bit. And it leads to this really nice relationship. Where again, that average temperature varying by about a degree, you can see the response in the clock frequency, again, as the compute module decreases its clock frequency to stay under the temperature constraints. As I mentioned before, this hasn't caused any adverse behavior in our payload. We're continuing to run our experiment, and it's been successful so far. But as you, as an operator, might want to know that. The bigger question for me, and again, as providing some advice to future spacecraft and payload builders, is why wasn't this caught in testing? Those two photos you can see are the thermal setup that I built for just subsystem level TVAC. This was before the payload was integrated into the entire spacecraft and did a system level TVAC. I've made another video about this TVAC setup that you can go look at if you want more information. But the takeaways here are really that we were in a pretty weak vacuum, so there still could have been some air inside the chamber helping to convect some of that heat away. You'll also notice that this was not flight attachments, so this wasn't in its installed configuration, and so the heat pass may have been a little different in this chamber than on the actual spacecraft. And also it might just not have been hot enough. You can see that I brought the water to about 40 degrees Celsius, for the bath that the chamber was in, but that water doesn't go all the way up the sides of the chamber. So I could have had a very hot side on the bottom where the water was, but then more ambient conditions up above, and that may have led to, again, not really getting hot enough to emulate the space conditions that we're seeing in orbit. If we look at the ground testing data after the payload was integrated into the spacecraft, you see this. So that most of this was done in ambient air, not in TVAC, but there is some system level TVAC data mixed in here. And you can see that we had a few boots that did run for a couple of hours. But again, in ambient air, you just don't get up to high enough temperatures to cause the throttling. I point out that one data point in the top left that did get up to 75 degrees C. And if we look at that boot in particular, you can see we only have 2 data points. So the payload in this hot case that was being tested wasn't ran very long. The payload ran for less than 10 minutes. And as we saw in the orbital plots, it takes an hour for the compute module to really get up to temperature. So we observed some higher temperatures during our ground testing, but we just didn't run the payload long enough for that to cause any issues and make us aware of the problem. Which brings me to, again, another reason why this wasn't caught in testing was the payload just wasn't operated long enough when we were doing system level TVAC in the flight configuration. Some future recommendations for anyone else who might be thinking of using a CM4 for their spacecraft or their payloads. Again, number one, TVAC for a couple hours in flight configuration so you can see what you come to in those conditions. Secondly, we obviously should have added a thermal strap or a doubler to help transfer some of that heat away from the processor and get it away from the computer to the rest of the spacecraft. And one other thing we could have done was changed our architecture. We could have used a lower power microcontroller instead of the CM4. We didn't explore this option during development because we had a very short development window. And so we needed something that was already ready to use, that we were familiar with. But if we're going to do this again, we might explore some lower power options that would still be capable of running our payload. That brings me to the end of the things I wanted to talk about. Again, if you're thinking of using a CM4 on orbit, feel free to look up my contact info is in the UC Davis student directory. That is accessible to the public. I just don't want to put my email address here on YouTube where anyone can find it. So good luck on any of your future projects, and thanks for listening.